everyone, we're going to determine whether the series is absolutely convergent, conditionally convergent, or divergent. So we're going to use the ratio test to see if it's absolutely convergent, and that means our limit has to be less than 1. So we're taking the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. So what we're going to do for us is take the limit as n approaches infinity, and then a sub n plus 1, you just put n plus 1. So this is going to be negative 3 to the power of n plus 1 divided by 2 times n plus 1 plus 1, and this is to factorial. All right. Then what we're going to do is divide by a sub n. But dividing by a sub n, since we have a fraction, is the same as multiplying by the reciprocal. So for the numerator, we have 2n plus 1 factorial divided by negative 3 to the power of n. Now, as a side note, and this is absolute value, let's do a little bit of simplifying. Let's look at these two right here. So if you have negative 3 to the n plus 1 power divided by negative 3 to the power of n, this is the same as negative 3 to the power of n plus 1 minus n, using your quotient property for exponents. So the n's cancel. So we're going to have the limit as n approaches infinity of absolute value of negative 3 for these two parts. For these two, let's look at what we have. We have, if I simplify this, let's write our numerator is going to be 2n plus 1 factorial. This right here is really 2n plus 2 plus 1 factorial. That gives me 2n plus 3 factorial. Now, I can simplify this right here and write this as 2n plus 3 times 2n plus 2. Remember, you're subtracting. And then 2n plus 1 factorial. And you could keep going on, but I'm stopping because my numerator is 2n plus 1. So we're left with this. So what we have is times, I'm going to erase this part, times 1 divided by 2n plus 3 times 2n plus 2. All right. Now, to simplify this further, let's factor out the absolute value of 3 is just 3. So we have the limit, 3 times the limit as n approaches infinity of 1 divided by 2n plus 3 times 2n plus 2. So as this denominator gets larger and larger, then this is going to go to 0. So we really have 3 times 0, which equals 0, which is less than 1. So according to our ratio test, part 1, since we have this, our series is going to be absolutely convergent. And I know I squeezed that in there, but when we took the limit, we got 3 times 0 equals 0, which is less than 1. So it satisfies part 1 of our ratio test. Thank you. Have a nice day. Bye-bye.